Okay, so this you had to fill out in your book already. Total surface area. We've done the perimeter, we've done the area in the previous chapters. This is your opportunity. You had to go fill it out. We're not going to go through that again, okay, because you've done it in other chapter. So then here we talked about our little cutout shape. We cut it out, we glued it together, and we're able to come up with these two formulas. So the total surface area is equal to 2 times my base area plus my perimeter of my base, as in my shape, my base shape we're working with, and then my height. So you see that my base area, what you're talking about, and my perimeter of my base, you related to the same thing. So if it's a triangular prism, okay, if it's a triangular prism, what do you think my base is going to be? My base is a triangle, because it's a triangular prism. If it is a circular prism or cylinder, what's my base shape? A circle. If it is a rectangular prism, okay, or square prism, okay, my base shape is a square. Okay, so basically they're taking the three main shapes that you know: square, rectangle, okay, square, rectangle, kind of all mixed in here, length times breadth, triangle, and the circle, and we're basically just expanding it into 3 dimensions. Yes?
So basically, what is the shape is that? The shape name, the base is that?
Yes, that's exactly that. So if it's a triangular prism, okay, what is the base shape? Triangle, perfect. And we know the area for a triangle, half base times height. Cylinder is going to be pi r squared. A rectangle or square or something like that, length times breadth. Okay. What if, for whatever reason, okay, it was some like kind of this, it's like almost like a rhomboid. It's a rhomboid prism. Okay, what's my base shape there going to be? A rhombus. And what's the area for rhombus? Something times something. It's my base times my perpendicular height. Okay, we're on the same track. So when we're looking at this I said is very important, the conversions. This is very important for this chapter. So if you haven't written it down, write it in now. 1 centimeter cubed, because we're talking about volume, is equal to 1 milliliter. So we're talking about distance, okay, meters, centimeters, so on. Mass talks about grams, and capacity talks about liters. Now there's a difference between volume and capacity. Now capacity, its unit is liters, okay. Volume is centimeters cubed or meters cubed, okay. You have to know which one's which. So in your little conversion table, 1 centimeter cubed is equal to 1 milliliter. 1,000 milliliters is equal to 1 liter. Obviously, we've done that conversion thing before. Okay, and 1,000 liters is obviously equal to 1 kiloliter, because kilo means 1,000. Okay, so converting volume. So we have 7 meters cubed. We need to get to centimeters cubed. How are we going to do that? We're going to say 7 multiplied. Okay, 7 multiplied. And then what's my conversion to get from meters to centimeters? What do I do? Times by 100. Okay, meters to centimeters. But now it is volume. So what we're going to do? We're going to cube it. Yes, exactly that. So we have equal to, how many is that? That's 7. 1, 2, 3, 4, 5, 6 zeros. Okay, plug it in your calculator, you'll get the same thing. Okay, now have a look. 1 centimeter cubed is equal to 1 milliliter. Okay, so how many milliliters is 7 million centimeters cubed? It's 1 to 1, so it's exactly the same. So it's a 7 million milliliters. Okay. Now, if we want to take that, okay, to kiloliters, okay, we over here, we at milliliters, we at milli, okay. What do we have to do to get from milli to the main one, from there to there? What we divide by 1,000, okay. And then get the main one down up to kilo. What do we do? Divide by 1,000. So you see, there's it there. Divide by 1,000. Yes. Okay. So if we're going up, so we're going up higher, it's divide. If we're going down, it's times. Okay. So go that way, it's multiplication. This way, it is division. Okay. So we need to divide by 1,000. 1,000. So how many zeros is that? 1,000, 1,000. How many zeros? There's 3 in the first 1,000 and 3 in the second 1,000. So how many zeros are we getting rid of? 6, exactly. 7. So here is another conversion for you, okay, that you must write there somewhere on your conversion table. Okay, 1 meter cubed is equal to how many kiloliters? How many kiloliters in 1 meter cubed? Have a look. Have a look where we started, where we ended. Okay, so it's a 1 to 1. Yes, so there's 1. There we go. So 1 meter cubed is equal to 1 kiloliter. Okay, we're understanding things. Let's have a look again. 4 kilometers cubed to meters cubed. Okay, so we're taking from kilometers to meters. What do we do? Kilometers to meters. Find it here. Kilometers. Okay, kilometers. So we're going to go from there and we're going to go there. So we're going to times 1,000. No. So it's going to be 4 times 1,000. But what we're going to do, because it's what we're going to do, power of 3. We must times the conversion as well. Okay, I'm not going to write it there. There's too little space. So it's going to be 4. And then 1, 2, 3, first 1,000. 1, 2, 3, second 1,000. 1, 2, 3, third 1,000. So if you plug that in your calculator, you should get that. It's 4 trillion, I think. Yeah. 1,000, million, billion. Oh, it's billion, not trillion. Apologies. Okay. So it's 40 billion meters cubed. Units are important in this section. Okay. So have a look at our previous conversion. 1 meter cubed is equal to 1 kiloliter. So how many kiloliters are there? How many kiloliters are there? 1 meter cubed is equal to 1 kiloliter. So it's 4 billion. So it's 4 with 9 zeros. Okay. 4. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Now, have a look at the next one. We have to go from kiloliters to liters. K to the main one. Kiloliter to just liter. What we got to do? We got to times by 1,000. Yes. Times 1,000. Okay. So, okay, enough. So we need to add another, how many zeros on there? We need to add another 3 zeros. So it's going to be 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we need to add on the other 3. We need to times it again by 1,000. So it's going to be 1, 2, 3. Okay. There's lots of zeros there. So there's 12 zeros. Now understand, there's a lot of numbers. It's very big. It's very confusing. Okay. But you just need to have a look at it and write down slowly. All right. Everyone good with conversions? We've done something similar. So let's move on. Surface area, volume, and capacity. So what did they say here? It is a what? What is it? Rectangular based prism. So what is my base going to be? Rectangle, exactly. So complete the total surface area, volume, and capacity of the following right prism. So there's it there. So let's do the total surface area first. Yes. Pardon? No? You've done that before. Go back a couple, previous section. You've done that. Okay, I'm not doing it again in class. So the total, oh, that's not a T. Total surface area is equal to, now what did we say my formula was? 2 times my base area, okay, area, plus my perimeter of my base multiplied by my height. And that height comes from what? The expanded portion. That makes it a prism. Okay, so it goes from just a two-dimensional boop, into a three-dimensional shape. Okay. So, there we go. So we're going to have here 2 times my base area is we agreed was a rectangle. So it's length times breadth. Okay. And then what is my length of my, you see, which one are we going to use as my base shape? Is it this here, which is facing us, which is very in our face, or is it this odd looking here on the side? The first one. That's obviously going to be the first one. So it's that one there. So it's going to be 4 times 5. Then we're going to add. Okay. Now what's the perimeter of my base shape? What's the total perimeter of this base shape? What's it going to be? So it's 4 plus 5 plus 4 plus 5. It's going to be what? 18. Yes. And my height is 11. Beautiful stuff. So we're going to have here 2 times 20 plus 18 times 11. Where's my calculator? I'll get it out. 198. Thank you. Where is my other bag? Oh, it's the thing I'm squashing the whole time. Okay. 198 you said. What's it? 198. Okay. So we add those two together. So 40 plus 198, what we're going to get? No. No. Okay.
138.
It's going to be 238. Now, what is the unit they used? They used centimeters. Okay. And did we work out the area, volume, or perimeter? We worked out the area. So it is centimeters squared. Okay. Centimeters squared. Total surface area. Okay. Yes. The 18 from. Okay. So remember again, just let's go back a little quickly. This is my formula. The perimeter of my base shape. We decided that this is my base shape here. This rectangle. We've got to find the perimeter of it. Now it's a rectangle, so the opposite sides are equal. 4 and 5. So 5 plus 4 is 9, plus another 5 is 14, plus 4 is going to be 18. So that's where the 18 comes from. It's very specific. They want the perimeter of my base shape. Perimeter. Okay. So now we need to work out the volume. Now this one's a lot more easier. So my volume is going to be equal to, it's a rectangular base shape, so my volume formula was what? My volume formula is my base area, okay, my base area times my height. And what is my height? It's my perpendicular component that makes it expanded into 3 dimensions. So it's going to be, the base here is a rectangle, so it's obviously length times breadth times my height, which is going to be 4 times 5 times 11. Okay, agreed? So 20 times 11 going to be, thank you very much. So we're going to have 220. What's the unit going to be? Centimeters cubed. So that's the volume. Now we need to change it to capacity. So capacity is liters, things with liters. So we know conversion, 1 centimeter cubed is how many moles? 1 centimeter cubed is how many moles? 1. So what's the capacity of this going to be? 220 milliliters. Capacity. Okay. 200. Oh, that's not a. 220 milliliters. Okay. You guys see it? You guys see it? Okay. Now this, it's a rinse and repeat. It's rinse and repeat. So, ready, let's go to the next one. Calculate the total surface area, volume, capacity of moles in the cube. Okay, do it now, quickly. Go, go, go. Okay, so we said it is a cube. No? And because of that, okay, so because of that, let's record. So we're going to say here, total surface area is equal to 2 times, it's a cube, so it's going to be 20 times 20, no? Okay, plus my perimeter. What's my perimeter going to be? 20 plus 20 plus 20 plus 20, so it's going to be 80. And then what's my height going to be? 20 again as well. So my total surface area, 2 times. Okay, any questions about that one? Okay. Millimeters cubed. Yes. Okay, so my volume is equal to length times breadth times height. Because why is it length times breadth times height? Because we said it's my base area, length times breadth, multiplied by my height. So it's going to be 20 times 20 times 20, no? Which is going to be what? What's my volume? 8,000 millimeters cubed. Okay, so where did I make the error? See, I made the error there. I said cubed should be square. Okay, none of you saw it. Or did you see it and just let me suffer? Okay. Okay. So now they want the capacity in milliliters. Now we know the conversion is from 1 centimeters cubed is equal to 1 milliliter. Now we don't have centimeters cubed. We have millimeters cubed. So we have to change something. Okay. So how are we going to get 8,000 millimeters cubed into centimeters? How do you change millimeters to meters? Millimeters to centimeters? Sorry? Divide by 10. Exactly. So what we're going to do, we're going to divide, okay, by 10. But now why are we going to cube the conversion? Because we're talking about it in terms of volume. Okay. So we're going to end up with 8 centimeters cubed. Now, what's a conversion for centimeters to liters? It's a 1-to-1. So it's just going to be 8 milliliters. Okay, look for me first. What's this? What am I highlighting? Homework. It is here. Okay. There's 4 sums. Easy, quick to do. Okay. That's it there. Okay. Highlight it. It's in your book. That's your homework there. Don't leave your book at home and come ask me later. So, what's the homework? Okay. Because sometimes I'm not going to remember. It's been a long day sometimes. Okay. So, now we're going to be talking about what? Triangular-based prisms. So, what do we know about triangular-based prisms? What's my base area going to be? It relates everything to triangles. Yes. Beautiful stuff. Okay. So, what's important to know about these triangulars, prisms? What's this? The 90 degree. Why is that important? Okay, Pythagoras, yes, if they ask you to find the other side. Why do we need to find the other side? Why do we need to find what this side is here?
The base.
No. It starts with the P word. The perimeter of the base shape. Yes. Okay, so let's work that out first. Okay, couple of you lost marks because you didn't put Pythagoras. So let's go and find you. So my hypotenuse squared, okay, is equal to 6 squared plus 8 squared. No? And the reason? Pythag. Yes, don't forget it. Anything we learned in those few chapters, you have to do. Yes. The reason, it's Pythagoras. Okay, so it's usually in like it's for 1 mark, and then if you forget your reason, it's 1 mark lost over the whole paper. Okay, but oftentimes that 1 mark makes a difference. Okay, so don't be forgetting easy things like that. So let's have a look. So my hypotenuse squared is equal to 36 plus 64. So my h is equal to a root 100. So then what is it going to be? 10 what? Centimeters. Yes, that unit is important with this section. Okay, so it's going to be 10 centimeters. Okay, so we have our height and my base. Now tell me again, what else is that 90 degree important for when it comes to finding area? What's the formula for triangle? Formula for triangle is perpendicular height. Yes, you have to use the 2 sides that are touching the 90 degree. Because if you say half times 6 times 10, that's not right. It's half times 6 times 8. Okay. So now that we got our other side here, we're going to find the total surface area. So my TSA, my total surface area, is equal to, okay, so I'm going to write it out again, 2 times my base area, okay, which is going to be what? It's going to be what's my base area? Triangle. So have that in your head. Plus the perimeter of my base shape multiplied by my height. And my height is what component? It's the thing that's making it a prism. It's the thing that's stretching it out. So what's the thing that's stretching it out? Yes, there we go. That's my height. Beautiful stuff. So we're going to have it here. So we're going to say 2 times a half times my base is 8. My height is going to be 6 there. You see it, plus the perimeter. What's my perimeter? 10 plus 6 plus 8. It's going to be 34. 24. Are you sure? Just checking. I was questioning you guys. Just checking. 24. And my height is going to be 11.5. Yes. Where did I put a half? Here. Because it's my base shape is a triangle. Okay. And a triangle area is, so the area of a triangle is half times the base times my perpendicular height. So that's where that half is coming from. Okay. So if we plug that into my calculator, what we're going to get? Pardon? 324. Thank you. Now, what's my unit? Centimeters squared. Why is it squared? It's area. Yes. Okay. So my volume is going to be what? My volume is my base area. Okay. Multiplied by my height. Again, where does that height come from? There's it there. It's the thing that's making it into a prism. So, I'm going to put it over here. So, our base area, what did we work out? Half times 8 times 6. We're multiplying it by 11.5. Okay. So what we're going to get there? I get 276. Okay, and it's going to be centimeters, but what we're going to put by the centimeters? Cubed. Why is it cubed? Volume. Yes. Okay. And then the last thing, what they're asking for, the capacity. Now, capacity talks about liters, capacity. And now from our conversion, what's my conversion for capacity? 1 to 1. So 1 centimeter cubed is equal to 1 milliliter. So what's the capacity here? Exactly. So it is going to be 276 milliliters. Okay. 276 milliliters. Yes. Come from? The height comes from the thing that's making it into a prism. Okay. So if we have, let me try here quickly. Okay. So if we have a base triangle that looks like that, and we have a prism, okay, that's a very, very accurate, trust me, okay. Okay, so there's my shape. Okay, so here is the base things here. If it's not 90 degrees there, they're going to show you somewhere where the 90 degrees, because that's important to know about for triangles, the perpendicular height. Okay, so the height comes from, again, this here. The height is the thing that makes it from a one-dimensional, whoopsie, no, let's change that quickly. From a two-dimensional shape of a triangle, and the height makes it now into the 3 dimensions. So do you see that there isn't the highlighted part here in this over here? There's nothing here. Okay, so it's 2-dimensional. We add this height or this depth, however you want to call it. Okay, it now becomes 3-dimensional. Okay, that's good. Okay, last example, last one. You ready? Last one. Okay, last one. Let's look at it quickly. So, total surface area, volume, capacity of the following triangular prism. What's my base shape going to be? Triangle. So what do you know? What do we have to have about that? That's important. The right angle. So it's going to help us how? In 2 ways. What's the first way? And then finding the perpendicular height. Yes. So let's find the other side. So the side squared is equal to the hypotenuse squared minus the side squared. And then Pythag. You must have Pythag there. If there's no Pythag, it's wrong. Okay. So let's work it out. So it's going to be 21 squared minus 12 squared. Oopsie. 21 squared minus 12 squared. $17.23. What? Millimeters. No unit, no mark. Millimeters. It's very important. Okay. So this side, the perpendicular height we have found here is going to be 17.23. So now we're going to start. Totals. Let's move it up a bit. Total surface area is equal to 2 times my base area, no, multiplied by, oh no, what's it? 2 times the base area plus the perimeter of my base multiplied by the height. And again, where does that height come from? It's not the one we just worked out. It's the 9. It's the thing that's making it into a prism. Okay. So let's substitute in. So it's going to be 2 times the base area. It's a triangle, so it's going to be a half. And then times by 12 times by what? Yes, not the 21. 17.23. Okay. Plus my perimeter, what's it going to be? 21 plus 12 plus 17.23. And my height here is going to be? What's it? 9. My height is 9. I'll highlight it there so you can see it nicely. Okay. So plug that into a calculator and what do we get? We're going to get what did you guys get? Did you get the same as me? Okay, what did you get? 598. Okay, so what's my unit here going to be? Millimeters squared. There. Now, next thing, last quickly. Let's go. Nearly a few more minutes. We got this. So, volume is equal to what? The base area, which is a what? What's the base area in this case? It's a triangle times my height. Where do we get that height from again? It's this here. It's this 9. It's the thing that's making it into a prism. Okay. So we're going to say half times 12 times 17.23. And then my height is going to be 9. So work that out, what we're going to get. What do you get? 9? Nine 30.42. What's my unit? Millimeter cubed, because it's a volume. Cubed. Okay. So now they want the capacity in moles. We've got to take this and convert it to what first? What's our conversion for milliliters? 1 centimeter cubed is equal to 1 milliliter. Okay. That's important. I'm going to put a big box around it so you can see it again. Okay. Now, so what's it going to be? We're going to change this up. Okay, so 930.42 millimeter cubed. What you have to change from millimeters to centimeters, we're going to times or divide. We're going to go up. We're going to divide by 10. And because it's volume, what we're going to do to our conversion? Cube it, because it's a volume. No. We're going to convert it. So that is equal to 0.93. What's it? 0.93 centimeters cubed. Centimeters cubed. So if our conversion is 1 centimeter cubed is equal to 1 milliliter, it's a 1-to-1. So what's the capacity of this? My capacity.
0.93.
Exactly. My capacity is 0.93 milliliters. Okay. So We'll go back, promise. So, have a look here. What's this I'm highlighting? Okay, there's it there. Okay, so